Hello, here's challenge B, and we're going to sort of go through this, but you know I have to make you think and do it by yourselves. So I'm going to walk you through the process, and you're going to have to do the calculations, and we'll check them the next class period at 7:30 in the morning. So this is going to be a combination again of everything you know. First thing you want to do is find the percent of each compound. Step 1, find the percent. I guess I should say of each atom in each compound. So I'll give you a refresher, and then you can do the rest of them on your own. We're going to make a few assumptions, and I want you to check something. So the first assumption we're going to make is that all of the hydrogen is in this water molecule. Okay, so we're not going to worry about this hydrogen, this proton that's attached to the nitric acid. So that's not going to be a source of hydrogen. Although, everything else is going to be a source of oxygen. And then we'll talk about that in greater detail. So let's first find the percent of carbon in our first sample. So you're going to do this for each sample. So we're going to do sample 1 first, and then you have to go do sample 2 by itself as if it was a completely new problem, and then sample 3 by itself as if it were a completely new problem. So to figure out the percent of carbon in carbon dioxide in the first sample, because our source of carbon here is going to come all from this carbon, or from carbon dioxide. So since it produced 4.23 grams of carbon dioxide, that's our only source of carbon. So we have 4.23 grams of carbon dioxide. Going to moles, we got to make everything equivalent. And then from every 1 mole of carbon dioxide, this is kind of a step you can probably skip, but I just want you to see it. So every 1 mole of carbon dioxide is going to produce 1 mole of carbon. And then from there we're going to figure out our grams of carbon. Because we're going to do this differently, we're going to find our percentage of carbon first. So we need to go to grams to figure out what percent of 2.52 grams is carbon. Again, what percent of 2.52 grams is carbon? Okay, so we do all of that math, and I get somewhere around 1.15 grams of carbon. To get our percent of carbon, if our whole sample is 2.52 grams, the part of it that's carbon is 1.15 grams of carbon. Divide that by 2.52 grams total. And of course multiply by 100, but you knew that. And somewhere you get 45.82% carbon from that compound. So we're just going to keep that number. You're going to do the same process for hydrogen in that compound. You're going to do a similar process for the sulfur in this compound, and then for the nitrogen in this compound. Once that's all done, once you have percent hydrogen, oops, sorry, I want to turn that to red. I don't want that blue. Once you have your percent hydrogen, your percent sulfur, and your percent nitrogen, how are you going to get your percent oxygen? Well, of course. You're going to add up all those percentages and subtract it from 100, and that'll get you your percent oxygen. So keep watching. I'll give you what the percentage should be, so I'll let you know, so you can check yourselves. Okay, step 1 is finished. Okay, I'm not sure how much you guys got there. So we found, step 1 was find our percent composition of the compound, and you did that. Now, it's just a straight up empirical formula problem from percent comp that you guys already know how to do. So step 2, assume 100 of the compounds. So that gives us 45.82 grams of carbon, 4.49 grams of hydrogen, etc. Once you do that, convert to moles. So go from your grams to your moles. And when you do that, you should end up with the following moles. And your last step, step 4, convert to the lowest whole number ratio. How about lowest? To lowest. So I'll leave that to your capable hands. Good luck with that. And Monday, 7:30, we'll give you this compound and see how well you did. Good luck.